I'm Dr. Manisha, Assistant Professor from Physics Department, KVN Naik College, Nasik. In this series of lecture, this is our today's third lecture. In this lecture, we will study about planetary model of hydrogen atom. Classical model of hydrogen atom consider a single electron in a circular orbit around the nucleus. Such a model is often referred to as a planetary model. The nucleus has charge plus Ze. Here is the nucleus which is having charge Ze. So we are attempting to describe hydrogen, helium plus, lithium plus plus, and the centripetal force required for the circular motion must be balanced by the Coulomb force. Classical physics predicts that the atom should collapse in a fraction of a second. Failure of this classical physics. We have learned several notable failures of the classical physics in describing some phenomenon. First is lack of dependence with light intensity of a photoelectric effect. Second one is lack of quantization of atomic emission and absorption spectra. Third one is collapse of atoms. Thus, new law of physics must be derived for atomic physics. The Bohr model of the hydrogen atom is the first step towards the new quantum mechanics. Bohr's postulate. In 1913, Bohr proposed the several postulates in an attempt to describe the atom. The first postulate states that an atom consists of a small heavy central part called as nucleus, in which the whole of the mass and the positive charge of the atom are concentrated. The negatively charged electrons and they are revolving around the nucleus in a closed circular orbit. The centripetal force required for this circular motion, it is provided by the electrostatic force between the positively charged nucleus and negatively charged electrons. Thus, the electrostatic force of the attraction between these two nucleus and electron is given as Fe is equal to 1 upon 4 pi epsilon 0 Ze square upon R square, where 1 upon 4 pi epsilon 0 is a constant. The necessary centripetal force required for this circular motion is given as Fc is equal to mv square upon r. Hence, according to the first postulate of Bohr's theory, this centripetal force is equal to the electrostatic force of attraction between the positively charged nucleus and negatively charged electron. Thus, mv square upon r, which is a centripetal force, that is equal to this electrostatic force, that is 1 upon 4 pi epsilon 0 Ze square upon r square. The second postulate states that the electron revolve only in the certain specified non-radiating orbits called as stationary orbits, and when the electrons revolve in these orbits, there is no loss of energy at all. Bohr showed that the electron can only occupy such orbit for which the angular momentum of the moving electron is an integral multiple of h upon 2 pi, where h is the Planck's constant. Thus, for any given orbit, the momentum of the electron is given as m into v, that is m is the mass and v is the velocity, and the angular momentum is given as mvr, r is the radius. So according to the second postulate of Bohr's theory, this angular momentum, it is equal to n, that is the integral multiple of h upon 2 pi. So mvr is equal to n h upon 2 pi, where n is the integer having values 1, 2, 3 and so on, and these are called as principal quantum numbers. The third postulate states that when an electron jumps from one orbit of higher energy to the another orbit of lower energy, the energy is emitted in the form of radiation. The amount of energy emitted is the difference between the energies of the electron in these two orbits. Thus, an atom may emit or absorb energy from the photons only when the one electron of the atom jumps from the higher to lower orbit of the form higher orbit respectively. That is equal to h nu, and this is equal to Ei minus Ef. Ei is the energy of the initial state and Ef is the energy of final state, and the condition is that this Ei should be greater than Ef. Now we'll study about the radius of Bohr's orbit. Just now we have seen that from the third postulate of Bohr's theory, the difference in their energies, that is Ei minus Ef, is equal to h nu. For the hydrogen atom, this Z is always equal to 1. So according to the first postulate of Bohr's theory, this centripetal force required for the circular motion of electron, it is equal to electrostatic force of attraction between the nucleus and electron. So it is mv square upon r, which is equal to 1 upon 4 pi epsilon 0 into E square upon R square. Multiplying Throughout this equation by m, we'll get it as m square v square is equal to 1 upon 4 pi epsilon 0 m e square upon r. From the second postulate of Bohr's theory, we know that the angular momentum is equal to integral multiple of h upon 2 pi. So it is mvr is equal to nh upon 2 pi. Now squaring both the sides, we will get it as m square v square r square is equal to n square h square upon 4 pi square. Now if we'll rearrange a few terms, we can write m square v square is equal to n square h square upon 4 pi square r square. Now here we are getting the value of m square v square, and in this equation from first postulate of Bohr's theory, we are getting the value of m square v square as 1 upon 4 pi epsilon 0 m e square upon r. So equating these two right hand sides of these two equations, we can write n square h square upon 4 pi square r square is equal to 1 upon 4 pi epsilon 0 m e square upon r. So after rearranging these terms, we'll get the value of r, which is a radius, is equal to epsilon 0 n square upon pi m e square. Using the value of this r in equation number 2, we can write mv is equal to nh upon 2 pi into pi m e square upon epsilon 0 n square h square. If we'll rearrange few terms, we can get the value of v as e square upon 2v epsilon 0 nh. From the above equation, we get the radius of nth orbit of the Bohr's atom is Rn is equal to epsilon 0 n square h square upon pi m square. From this expression, we can say that Rn is directly proportional to the n square. That is, the electron cannot rotate in any arbitrary but in certain specified orbits in which the radius is proportional to the square of an integral number characterizing that orbit. Thus, the radii of orbits are in the ratio of 4s to 9s to 16s to and so on. The velocity of the electron in the nth orbit is v is equal to e square upon twice epsilon 0 nh. We know that the kinetic energy is equal to half of mv square. So substituting the value of this v in kinetic energy, we can get m e raised to 4 upon 8 epsilon 0 square n square h square. And the potential energy of the electron in the nth orbit is given as, when the potential energy of the electron when it is at a distance of r from the nucleus is measured by the work done in moving the electron from the distance r to infinity. So potential energy is equal to integration of 0 to infinity of f into dr. Substituting the value of this f as 1 upon 4 pi epsilon 0 e square upon r square into dr, will get, after solution, will get it as minus 1 upon 4 pi epsilon 0 e square upon r. Using these above values of potential energy and kinetic energy, we can write total energy as total energy of the electron in the nth orbit as kinetic energy plus potential energy, that is m e raised to 4 upon 8 epsilon 0 square n square h square minus this potential energy, that is m e raised to 4 epsilon 0 square n square h square. So after calculating this, we can get total energy as minus m e raised to 4 8 epsilon 0 square n square h square. Negative value shows that the electron is still bounded to the orbit. Thus the energy of the nth orbit is inversely proportional to the square of the principal quantum number, that is En is directly proportional to 1 upon n square. So friends, I hope you like this video, and in the next lecture we will study about the hydrogen spectrum. Don't forget to like, share and subscribe. Stay tuned. Thank you.